Welcome back, everyone. Today we're diving into something pretty cool. It's where AI meets, actually getting your hands dirty to learn.
Oh yeah, this is a fun one.
Yeah, so we're looking specifically at fourth and fifth grade math. Like if you wanted to use some really cool tech like computer vision and machine learning to teach math,
Yeah.
to make it fun for kids. The ones who really learn by doing.
Yeah, exactly. Not everyone learns the same way.
No,
And some kids, they gotta touch things and manipulate things. That's how they learn best.
absolutely.
Kinesthetic learners, they call them.
Yeah, so we're gonna look at this data science students project, right? And a conversation they had with a ChatGPT AI consultant,
Right.
and they're trying to put this all together. It's fascinating. So picture this, right? Kids learning math by actually moving beads on an abacus or sorting real coins.
Yeah, real world stuff.
Yeah, and the whole time there's an AI right there with them, giving them instant feedback,
Yeah.
telling them how they're doing, suggesting things. Pretty wild, right?
Yeah, it's really exciting to see this blend of cutting edge tech, and then this very hands-on, almost old school approach to education.
Yeah. I mean, it's bringing the abacus into the 21st century.
Yeah, totally. And the students project really focuses on those kinesthetic learners, right? The ones who, like I said, they thrive when they can actually, get their hands on what they're learning.
Okay, so let's unpack this project a little bit. First off, how is this student planning to use all this tech?
Well, they're planning on using a few key things. So first, you got computer vision, right? So the system can actually see what the student's doing.
Okay.
Then there's these things called YOLO models. YOLO,
Yeah.
which are basically like super powered Where's Waldo algorithms.
I love that analogy.
Yeah, they can identify specific objects in an image, so that way the AI knows exactly which coins are being used or how the abacus beads are arranged. So that it can actually understand what it's seeing, right?
Okay.
And then of course there's machine learning. That's the brains of the whole operation. It analyzes what the student's doing, and then provides feedback.
So it's like the AI is watching
Yeah.
and learning alongside the student.
Mm-hmm.
But let's get a little bit more specific here. The student wants to use actual physical objects,
Mm-hmm.
right?
Mm-hmm.
Like abacuses and money.
Yeah.
So paint me a picture. How would that actually work?
Okay, so imagine a math problem pops up on a screen, right?
Uh-huh.
But instead of just typing in the answer, the student has to actually physically move the abacus beads to represent that number, or maybe count out the correct change using, like you said, real coins.
That's really cool.
Yeah.
So, but how does it actually see what's happening with these objects? That's where computer vision comes in, right?
Exactly. So the student is exploring tools like MediaPipe and OpenCV, which are these amazing tools for tracking hand movements in real time. It's like giving the AI its own set of eyes to see what the kid is doing.
Okay, so the AI is watching.
Yeah.
What happens next?
So it sees what's going on,
Yeah.
and then it has to figure out, okay, is the student doing this right?
Right.
And even more importantly, how do they learn from this whole process?
Right.
And that's where machine learning really comes in. It's
Okay.
not just about, oh, you got the answer right or wrong.
Right.
It's about the whole process. How long did it take you to figure this out? How many times did you have to try? Are you focused? Are you getting distracted? It's gathering all this information, all this data to really understand, how each kid is learning.
Okay, so that brings us to, I think, one of the coolest parts of this whole thing, personalized feedback.
Right.
So how does the AI take all that data, all that information that it's gathering, and actually turn it into, help for the student?
It's think of it as having your own personal AI tutor,
Ah,
and it designs a learning plan just for you.
yeah.
So if you're flying through the problems, it's okay, let's make this a little more challenging.
Right.
Let's step it up a notch. But if you're struggling, it can, maybe go back a little bit, make it easier, give you more support.
Yeah.
And it can be really specific too. Let's say it sees that, oh, the student, they're taking way longer on subtraction problems when they have to borrow.
Yeah.
Well, then it could give a little mini lesson just on that, and maybe use the abacus to show you exactly what's going on.
Oh, that's cool. So it's constantly adapting
Yeah,
to how each student is learning best.
exactly.
That's amazing. But to do that, right, to give that level of personalized guidance,
Mhm.
the AI has to be pretty knowledgeable itself.
It does.
Right. It's not just about recognizing, oh, that's a coin, Or that's an abacus.
It has to actually understand the math.
Yeah,
Right.
yeah.
That's where something called a RAG comes in.
RAG.
Yeah. Retrieval-Augmented Generation. Sounds complicated.
It does sound kind of complicated.
But it's, let me try to simplify it.
Okay.
So imagine the AI has like this massive library, right?
Okay.
Of math knowledge.
Like a digital textbook, but on steroids.
Yeah.
Yeah.
Or even better, it's like having the entire internet of math knowledge right there.
Wow.
So like, let's say you're having trouble with fractions,
Right.
converting them to decimals.
Uh-huh.
The AI can use this ORGAG system to instantly pull up a super clear explanation and maybe even an example using those coins you're already messing with.
Oh, okay. That makes sense.
Yeah.
So what kind of information would this AI textbook need?
Well, it's got to be pretty comprehensive, right? So first, of course, you got to have explanations of all the math concepts, like what is addition, what is subtraction, what are fractions, all that stuff.
Right, the basics.
The basics, yeah, got to have that. But also you got to have examples of like the common mistakes students make, right? Because that's how you learn. You got to figure out where you went wrong.
Right, yeah.
And you got to show how different tasks are related.
Okay.
So like if you're learning multiplication, you got to understand how it builds upon addition, you know? It's about creating this detailed map of like the whole learning journey, you know?
So the AI can really guide the student along?
Yeah.
Okay, so that's a lot of information. How would the AI organize it all?
Well, that's where graph databases come in.
Okay.
So think of it like a giant web of knowledge, right?
Right.
Where each concept is a point on that web, and all the connections show how all those ideas relate to each other.
Okay, so like addition might be connected to multiplication because it's a building block.
Yeah, yeah.
And then both of those could be connected to like the tasks,
Yep.
like counting beads on the abacus
Yeah.
or solving word problems.
You got it. And then the AI, it can use this web to find the most relevant information for each student.
Yep.
It's pretty amazing, and we'll get into more detail on that in a bit.
Sounds good.
It's like, the AI really understands not just the facts, but how they all fit together.
Yeah, it's really about making those connections, right?
Yeah.
Not just memorizing things.
Right, exactly. It's more than that. It's about building like a real understanding. But we've been talking about abacuses and coins, but are those the only ways to do, hands-on learning with AI?
Oh, not at all. No. The student mentioned using MediaPipe
Right.
for hand tracking, which like opens up a ton of possibilities. Like imagine a student, air writing numbers with their fingers to solve a problem. The AI could totally pick that up.
Wow.
And understand what they're doing. So they're almost like conducting an orchestra of math with their hands.
Yeah, that's a great way to put it.
I love that.
And you could even take it further, right? Like, what if the AI tracked their whole body?
Okay.
You could have like math lessons that involve dance or movement challenges.
That would be amazing.
Yeah.
So much more engaging for kids.
Definitely.
So let's go back to the AI for a second.
Mm.
We've talked about how it understands the student's actions and gives feedback, but how does it actually grade their work? Like, how does it know how well they're doing overall?
That's a great question.
Yeah.
And it makes you think about how we design AI for education.
Right.
It's not like a traditional test.
Right. There's not just one right answer.
Yeah, exactly. Especially with hands-on learning, right? The process, how they get there, it's just as important as the final answer.
Because it's about the journey, not just the destination.
Yeah, exactly. We have to look at a lot of different things.
Okay.
Like how fast did they do it? Did they get stuck on certain parts?
Yeah.
Are they getting better over time?
So you need all of that.
We need all of that to really paint a full picture of what's going on.
It's almost like the AI has to become a learning scientist.
Yeah.
Just constantly observing, watching every little thing the student does.
It is. And that means we have to be really careful about what we're measuring, and why.
Like, what are we actually trying to teach them?
Exactly. Like, what are the goals? Are we focusing on speed, accuracy? Do we want them to really understand the concepts or all of the above? And then the AI has to be aligned with that.
Right. It's got to be measuring the right things.
It does.
Now, all this makes me wonder, what happens to the teacher in all of this?
Yeah.
I mean, if the AI is doing so much of the teaching, the feedback, the grading, what's left for the teacher to do?
That's a big question.
It is.
And it's something a lot of educators are thinking about right now with with AI coming into the classroom.
Yeah.
And, I think the teacher's role, it becomes more about being a facilitator
Okay.
or a guide. They're still super important
Yeah.
for creating like engaging lesson plans, making sure everyone feels good and supported, and building a good learning environment for the kids.
So it's not about replacing the teacher.
Yeah, no.
It's about giving them this powerful new tool
Exactly.
to do even more,
Yeah.
to personalize that learning even more for each student.
It's finding that balance between tech and good old-fashioned human interaction.
Okay, so let's switch gears for a second. Let's talk about actually building this thing.
Okay.
I mean, we've talked about Agge,
Yeah.
we've talked about graph databases, but what other tools, what other frameworks are out there that the student might use?
Well, let's get a little technical.
I love it.
So for natural language processing, especially when the AI has to generate feedback, it's got to sound good, right?
Yeah.
So they'll probably want to look at things like Hugging Face transformers,
Okay.
which have all these really powerful pre-trained language models.
Okay.
Like, GPT-3 or BERT. And those are amazing at understanding and generating actual human-like text.
So these are the same kinds of models that power things like chatbots.
Exactly.
Or language translation.
Yeah.
So it makes sense to use them here to make the AI feedback, sound more natural.
Right. And then when you need to pull information from that giant knowledge base we talked about, tools like Feijes or Pinecone, those are specifically designed for what they call similarity search, which basically means they can find the most relevant info super fast.
So the AI doesn't have to search through this whole mountain of data?
Exactly. It's like having a super fast, super smart librarian.
I love that.
Yeah.
Okay, that makes perfect sense. Now, what about the computer vision side of things?
Yes. So they'll need some really strong tools to process all that video from the camera.
Track the hands, recognize the objects. OpenCV is a great library for that.
Okay.
But MediaPipe also has some really good options for hand tracking and body tracking, which the student is interested in.
It's amazing to see how all these pieces work together.
It is.
But, choosing the right tools, that's just the first step.
It is.
Right. What about the user interface?
Oh, yeah, that's super important, especially for younger kids.
Especially for kids who, are hands-on learners.
Yeah.
It's got to be, fun and easy to use.
Exactly. It can't feel like a boring old-school software program.
Yeah,
it's got to be engaging.
Yeah.
Almost like a game.
Yeah, absolutely. Now, stepping back, thinking bigger picture here, how do you see this kind of AI system working in an actual classroom?
Well, that's the million-dollar question, right?
It is.
I mean, there's a lot to think about. How do we make it work with, what teachers are already doing?
Right.
How do we train teachers to use it?
Yeah, good point. These are all challenges, but that's part of what makes it so exciting. It's not just about the tech, It's about how we use it to really change how we teach and learn.
Yeah, it really feels like we're just scratching the surface here.
We are.
But the potential is just, it's incredible. I mean, it makes you wonder what could the future of education look like with these tools?
Well, I think we're moving towards a future where learning is truly personalized, It meets every student's needs, their learning styles, all of that. Imagine a classroom where every kid is empowered to learn at their own pace with an AI guide right there with them.
It's like giving every student their own personalized learning superpower.
Yeah, I like that.
But okay, before we wrap up, I want to touch on one last thing here. We've talked a lot about the AI, but to make all this work, you need the right kind of data.
Data.
Yeah, it's all about the data. So what does that look like in this system?
Well, the student and their AI consultant, they talked about different ways to store and organize all this data. And it does get a little complicated.
Okay, break it down for me. What kind of data are we even talking about?
Okay, so first you've got the actual educational content itself.
Right.
So all the math problems, explanations, examples, all the feedback the AI gives, all of that has to be stored in a way that the AI can easily find it and use it. They talked about using something called JSON.
JSON, okay.
Which it's a format that's really good for organizing this kind of information.
Okay, so each math problem would be packaged with its solution, with its explanation, or maybe different feedback options.
Exactly, exactly. And then you've got all the data about each student, how long did they take on a problem? Were they accurate? Did they need hints? That kind of stuff. That could be stored in something more like a spreadsheet, you know, or a database.
So the AI can track their progress.
Yes, yes, and see where they're doing well, where they might be struggling, and then adjust the difficulty. But then there's that whole thing about the AI understanding how all the different math concepts relate to each other.
Right, right. The big picture.
And that's where a graph database is really useful. Like we were saying before, each concept is a node in this giant web.
And then all those connections show how they all fit together.
Exactly. So addition is connected to multiplication because, it's a building block. And then both of those are connected to counting on the abacus or solving word problems.
And this way, the AI can really personalize that learning path for the student. But with all this data, it just seems like there's so much to manage. Are there tools to help with that?
Oh, yeah, there are. To find information quickly, they talked about tools like MATIs or Pinecone, which are specifically designed to do what's called similarity search. So they can go through tons of data really fast and find what's most relevant.
That's key, right? It has to be fast for that real-time feedback. You don't want the student waiting around.
Exactly, exactly. And it's not just about speed, it's also about accuracy. The AI has to find the right information, the stuff that will actually help the student right then and there.
Well, this has been a fantastic deep dive. I mean, we've covered so much. We've talked about kinesthetic learning, the AI, the data. It's really incredible to see how we can use technology to personalize education like this.
It is. It's really cool. It really shows what we can do, when we combine human creativity with the power of technology.
So as we wrap things up here, what would you say is the main takeaway for our listeners?
I would say think about the potential.
Yeah.
We're still early on in this AI learning journey, but the possibilities are huge. Think about what it would mean to have education that's truly designed for each individual student. That's what we're moving towards.
A future where technology helps both teachers and students.
Absolutely.
And where learning is it's more dynamic,
Yeah.
it's more personalized, and hopefully it's more effective.
It all starts with being curious, asking those what-if questions. What if learning was more engaging, more accessible? What if we could help every student really reach their full potential? Those are the questions that drive innovation.
Those are great questions. And we hope, as you continue your own learning journey, you'll keep asking them. Think about your own experiences. Would this kind of AI-driven learning, this hands-on approach, would that have made a difference for you? What subjects did you struggle with? And could this technology have helped? Keep exploring, stay curious, and keep asking those what-if questions.